Mm-mm. As I'm saying, we're gonna continue on the periodic table, and the next is selenium. Me and YouTube share the same birthday year. Solar panels.
So here's a sample of selenium, and we have a pattern from the bottom side, and it's in the form of a shot. Perhaps the one that amuses me most is that it's used in shampoos. Some people, as you know, get dandruff, which is caused by bacteria on their scalp. If you use compound, which is a ring, which is can be added to the shampoo, and that's a bactericide that will kill the bacteria that cause dandruff. So let's see that. You can hear it. Selenium. Beautiful Again, this is a mineral which is useful for us, and in fact, many people often use selenium for their diet. However, you have to be careful because compounds that make a sweet smell are sulfur compounds. So if you get selenium in your body, then you make similar compounds of selenium, but they smell much worse. And so it is said the bus when selenium chemists get on. And mercurium is even worse still.
Bromine.
It's red, white, and green. It's lab grown. So today we're going to look at bromine. So this is
Bromine is one of two liquid elements at standard room temperature.
there are not many elements with gallium and bromine. It's this beautiful red colour, and it has an unpleasant smell. Bromine comes from the Greek word a really horrible these were occupied in Europe. Well, in Europe is the Octel company can see the vapour of the bromine coming off. You see there's no really nice orange fumes which are coming off from the liquid, and then they're being drawn away by our fume hood. Bromine has a number of uses. It is particularly used in plastics as an additive to try and make them less flammable. If you're watching your videos on a screen which has a plastic surround, almost certainly that surround will contain bromine to make it less flammable. Bromine itself is strongly oxidizing, so we thought we'd do an oxidation reaction today. And that reaction is to take another element, and here we have aluminium. Simple wrap your dinner. Into the bromine. We'll put it in, and it generally first reaction to start. As I said, the aluminium is strongly oxidized. Oxidation and formation of aluminium tribromide.
Aw, parrots.
So the reaction is strongly exothermic, which means it gives out energy, and that energy then evaporates off excess bromine, which you can see coming off of the vapor. A wonderful exothermic reaction, very, very fast, very, very rapid, forming aluminium tribromide.
Move, please. Thank you. I didn't mean to do that. Next is something that other people will love. Krypton.
So krypton is one of the
Named after kryptonite. Krypton is kinda useless though.
my supervisor when I did my doctorate was the first person to discover that fluorine could react with krypton. But even that reaction requires quite bright light to break the bond between the fluorine atoms to get them to react. But krypton can also be used in lasers when mixtures of krypton and a fluorine-containing compound to generate very pulses or intense pulses of ultraviolet light. Some years ago we had a professor here who bought a really big krypton fluoride laser, and when he switched it on and the beam hit the wall, it built a hole right through the wall, so he knew where to make the hole to get his beam into the next lab.
Yeah, krypton's not really that useful. It's a noble gas.
Sodium, but perhaps a little bit more. So the metal itself is quite low energy. I'm not going to show you liquid now, but you can see there's 1 gram of the metal inside this glass ampule. It's very reactive, and we're going to explore its chemistry now by putting this into some water. Well, we've got this really neat device which Neil put together last Friday, and you can see it's got a hammer which is going to break the glass. Show us, Neil. What does it do, right? So when the hammer falls, literally, we'll break the glass, the rubidium will just drop into the big bucket of water that we got underneath. Rubidium is an alkali metal that comes between potassium and cesium.
Ooh.
Potassium and cesium are
Oh, wow.
Physics, right?
Stupid headset.
Because you can heat and get a vapor of rubidium atoms in a
Charged it all night, but you know.
and you can get very interesting effects from shining very intense laser light into rubidium atoms. And the rubidium atoms can do a whole series of different, very elegant physics experiments. So rubidium has got a life of its own in physics, but in chemistry, it's perhaps slightly neglected.
Say that too, Steph. Was that it?
Don't think I needed my safety screen.
Well, that wasn't very exciting, was it?
Sorry, Fox.
Yeah.
It's all gone.
You were right, it was just a fizzle.
Strontium. Oh my god, I love it when strontium burns. It makes a beautiful red color.
A Squarespace website with an expensive-looking template and a second job you're going to quit after your first solo show. Nervous parents and acid green.
Hey, Dad, you want to know something cool I did? Strontium burns that red, and it's beautiful. I was telling my parents. So in the lab, I burnt strontium and copper, and I put the strontium on the right of the flame, and I put the copper at the left. So so if you divide the flame into thirds, the left third burned at green, the right third burned at red, and the middle third burned at orange. So I made a flame that was triple colored, and it was beautiful. And one day I hope to repeat the experiment.
Strontium is unique in the periodic table because it's the only element that is named after somewhere in the United Kingdom. There are lots of elements that have been discovered in the UK, more than 10. It's not an obvious name like gallium after France or germanium after Germany. This one is named after a small village in Scotland called Strontium,
I've never been there. I hope we might make a field trip there sometime.
So here I am in Strontian. Now you can see I'm on my own, I'm not with the professor or anyone else, but I have managed to find the address of a local history expert, so I'm going to go and pay him a visit. You know I've come to the right place, because look over there, there's a rainbow.
In this village, the first strontium salts were discovered, or at least the first ones where the element was identified.
So I have a sample of strontium metal, so it's kind of granules, they're very big granules, it's large granules of strontium metal. It's kind of in the middle of the group 2 metals. It's relatively soft, so what we're going to try and do is file some strontium metal off of the granules.
I've never seen the element, I've never seen any strontium, and because of my particular age, when I grew up in the 1950s and 1960s, when atmospheric testing of nuclear weapons
strontium can be
widely.
Strontium-40 can be deposited as a nuclear material. Bombs go off.
Sinister feeling to it, because when nuclear explosions take place, when the uranium atom splits, some of the fragments are strontium. And they're not only strontium, but they're a radioactive form of strontium known as strontium-90.
Oh, I'm stupid. I forgot. It is strontium-90. I knew it, but I just...
There it goes. The 4th atomic bomb has been successfully detonated.
This radioactive material, because strontium is in the same group as calcium, when it is floating around in the air, could be absorbed by people and that incorporated into their bones or their teeth in place of calcium, which you normally find in bone and tooth enamel. People like me are radioactive. Doesn't explain my hair, but on the other hand, it was quite a serious problem.
So we need to take some strontium ions, and in this case I've got a small amount of strontium nitrate, okay? Now I'm going to take a small amount and put it into a test tube, so that I can mix it with some of our combustion mixture. Wow, what a fantastic reaction. Really, really energetic, lots of energy coming out, lots of hot steam, lots of hot...
See? It burns in red. I love burning strontium. Too bad I might not be able to get strontium because you have to have like a chemist's license.
Fantastic.
Technically, operationally, and militarily, Red Wing may be summarized in one word: success.
It's a radioactive element. When radioactive elements decay, they can damage
I get strontium
the cells
ion?
in the body that are close by. If it's in the air or something like that, the particles don't go far enough to cause any damage, but if they're incorporated in your body, there are cells very close by, and these can...
Predetermined radioactive fallout.
When atmospheric testing stopped, the amount of strontium-90 that was distributed across the world decreased rapidly.
Copper produces a... Copper produces a blue flame. No, copper produces a green flame.
Well, because albeit you can get strontianite all over the world, but this is unique because this comes from strontium.
Strontium is useful as well. You can make very reactive compounds with strontium. That's what people like me are interested in doing and seeing how they react. And they might be as useful as their magnesium counterparts, which are actually very useful in synthetic chemistry.
Strontium itself is an element which I think may become more important because as some of the other elements become harder to mine because we're going to discover new reactions of strontium in catalysts and things like that, and we'll realise that it has much more value than we've thought up till now.
Well, we're going to go up to the mine, and what we're going to do is we'll have a look at it what's left of it, because unfortunately there's not an awful lot left. Now you can see straight ahead of you that there's another scar there. Well, that's part of an old road that was used by the miners. They were coming to part of the lead mine. I've tried to improve and educate people as to what happened in the area, and like most people who collect historical data, you become very, very passionate about this sort of thing. Probably I get so passionate that I'm probably a boring old fart or something, you know.
So this is one of the granules of strontium metal. It's kind of dark on the outside at the moment. Hopefully we can get rid of kind of that layer of tarnish by filing it. Next we have our strontium. So you can see where we're kind of sort of filing off that tarnish. We're kind of very metallic luster, which is quite pretty.
So this is it. This is where the old lead mine was, that they found a mineral that was a little bit strange, and they called it strontianite. And then after more work, they were able to extract from it a new element. And that, of course, became known as strontium. And we have it now on the periodic table.
Yttrium. Okay, please tell me how to say that.
DiGiorno has 7 delicious crusts.
I don't know how to say. It's YTTRIUM.
Fresh baked deliciousness. There's a 5-star pizza for everyone in your family to love. It's not delivery, it's DiGiorno.
Light up your new year with a top-rated Cadillac.
They want to just sort of sneak up so you don't sprinkle any dirt down the bottom of this place where we turned it over. Yeah, okay. Look at that soil. It's all cake looking in it. It is.
Where are we? Look up yonder. To the left. Oh, wow.
Okay. Let me get the soil before you start whacking, okay? Oh, yeah. It's all glass covered.
Here, we can see evidence of the mining. Now, this mine closed many years ago.
The bottom is glass covered, Houston. Yeah, white glass.
So if we look into the quarry in the normal daylight, in the absence of the snow, it would look a bit like a lunar landscape.
No, that's the black stuff is the glass. That's the other's crystal. That's the crystalline rock.
Now, I say that for one specific reason, because during the Apollo program, the astronauts, they came back from the moon with bucket loads and bucket loads of moon rock and dust.
Oh, that part of it is. Very good.
And upon analysis, they were really, really surprised to find that there were a number of elements, including yttrium, which existed in a much, much higher abundance on the moon.
Which happens to be the deepest penetration that boulder made.
So we're in Ytterby in Sweden, and it's a really nice day, and we've come to the Ytterby quarry, or Ytterby Gruva, which is actually the birthplace for 4 of the elements. And really, the one we're going to talk about now is this one here, yttrium. It was first discovered in this quarry from a really horrible black lump of mineral, which people thought was coal. And over a period of about 40 years, from the late 1700s on, some scientists over in Arbo did a lot of work in refining this material, and they found a new earth, or yttria. Okay, this is yttrium and oxygen, and they couldn't get the oxygen out by using traditional reductive methods, metal-making methods like burning with carbon and charcoal.
Yttrium.
So
its periodic symbol can be used to make my name, like radium, yttrium, and curium.
With much more reactive element, potassium.
Those 3 elements together make my name.
Oxygen, and he made yttrium metal for the first time. Yttrium, it's used in a whole range of different things. It's used in semiconductors with this yttrium, barium, copper oxides, the 1, 2, 3 complexes as we know of, and it's used for a whole range of different applications. It's used in laser technologies to make very intense pulses of light, for technologies like CDs and LEDs, etc., but massive, massive area. Another activity or another use for yttrium is actually in the use of yttrium oxysulfide, which is used as an additive in glass. It makes glass really tough, like bulletproof glass. It makes it shock resistant and very, very, very resistant towards temperature changes. So it's a very useful additive in glasses and glassy materials. Make sure you don't fall over the rock. So yttrium itself is a really quite nice, lustrous, soft metal from group 3 of the periodic table. It burns really readily in an oxygen-rich atmosphere and reacts quite well with water in the atmosphere as well. So you have to be very careful with yttrium because it oxidizes and it's really quite easy to destroy.
That's yttrium metal, just as turnings. So we have to handle this under nitrogen because generally it will form an oxide layer and then you won't be able to do any chemistry with it.
Yttrium is an element which is not, again, particularly widely studied in chemistry, much less so than its neighbour zirconium, and it's, but again, it's an area where chemists now are beginning to focus on rather more.
If it's really finely divided, then it might burst into flames. In fact, all metals, if they're very finely divided, they're quite likely to spontaneously combust.
Zirconium. One of the only elements that has a Z in its symbol.
It's not very often that I get two samples, and even rarer that I get two samples that are very different. But with zirconium, I've had one sample, which is big lumps of metal. This comes from a company that supplies large quantities of specialist metals to customers. The other sample is a very fine powder of zirconium, which was sent to me by a technician at St Paul's School in London, and I've given the powder sample to Neil to see what he can do with it.
So Neil, what are you going to do with this powder?
This sample is interesting, first of all, because it's relatively light. Zirconium is in the middle of the periodic table, and so although these look large lumps, they're not very heavy.
Can I feel?
It's interesting, first of all, and so although the periodic powder sample to Neil to see what he can do with it.
So Neil, what are you going to do with this powder?
This sample is interesting. First, zirconium. In fact, you may have seen from some of my earlier videos, I have a vodka glass, also made from zirconium. But it's not a glass, it's a vodka container. And when I need cheering up, I drink from it. But the big problem of zirconium is separating it from hafnium. So with my sample came a really quite comprehensive analytical data of all the different elements that they've tested for. And if you look down, these numbers here in the columns are in parts per million. And they're all very, very small. There's a tiny amount of tellurium or barium or neodymium. But when you get to hafnium, here, it's got really quite a lot. 250 parts per million. And the reason why you need to purify the hafnium is because in nuclear applications, hafnium can absorb neutrons and therefore could spoil the behaviour of the fuel in a nuclear reactor. It's hard to separate because hafnium and zirconium are in the same group of the periodic table and their chemical properties are very similar. When two elements have similar chemical properties, they're always hard to separate.
Nice.
The fuel in a nuclear reactor is usually some form of uranium oxide, which cannot be made into nice rods. So you put them essentially into a can, rather similar to my vodka glass, but a long tubular can, which gives them the mechanical rigidity so you can lower them in and out of the nuclear reactor. The outer coating is made out of zirconium. The problem comes when things go wrong in the nuclear reactor, because at very high temperature, zirconium can react with the steam in the nuclear reactor. The steam comes from the water that is used to cool the reactor, and zirconium can extract the oxygen from water to make zirconium oxide and hydrogen. So you can generate zirconium oxide, which causes the fuel rods to start falling to bits, and at the same time hydrogen, which can mix with air and explode. And you will have seen pictures of exploding nuclear reactors, for example Chernobyl, or more recently at Fukushima, because of this reaction between fuel, cladding and steam.
Why don't we not use zirconium in our cladding?
Well, zirconium has the right properties to, from the nuclear point of view, and many other elements also react with steam at high temperature. Iron does, for example, and iron rusts as well, so that would be even more problems. So you can't get round the fact that most metals at high temperature will form oxides. Zirconium oxide is actually quite an abundant material. Apparently, there's some beaches in Australia, in the northern part, which are, the sand is mostly zirconia, so it's zirconium oxide. So it's a really quite abundant element, so it's not going to be one that is going to run out very soon, compared to some of the other really rare elements.
Niobium.
It's school. It's open. It's closed. It's online.
Element 41 is niobium. And I'd never seen niobium until recently. And then I was lent a medal. I haven't won the medal, but it is a medal that is given each year to somebody who's made a real contribution to the field of niobium chemistry or niobium science. The medal is made out of niobium. So look carefully. This is metallic niobium. I can't remember who won it last year, but it has been won by a series of people, mostly in the field of metallurgy. And I'll explain why it's metallurgy rather than chemistry in a minute.
But who gave you that one, Professor?
I was lent this by the company CBMM, which awards this medal, together with the Institute of Materials and Minerals. It is named after Charles Hatchett, who was the English scientist who discovered niobium, or discovered the element initially. And it's really quite interesting. It was at the beginning of...
I've actually read something pretty interesting last night, is that one of the effects of autism is the obsessive disorder to line things up, and I actually feel as if I'm affected by that. I always feel the need to line something up perfectly. I always feel the need to measure perfectly, and that's probably why in Minecraft I build with odds, not evens. With evens, but very, very, very rarely. For example, look at this room. It is 7 blocks wide by 4 blocks wide. It's 4 blocks long, but it's got an odd number to it. Why do I like odd numbers? Because there's a middle to an odd number. There's a middle block that can be...
niobium, or discover the element.
Molybdenum. Molybdenum. Oh my god.
The idea of elements had been published, so everybody was looking for elements, and Charles Hatchett looked at a mineral which had been in a museum in London for quite a long time, a mineral that came from America, and he discovered a new element. And because it came from America, he called it columbium, because Columbia is the Latin name that is often used for America. And I think the name columbium sounds really beautiful.
You're normally really opposed to naming elements after countries.
Well, I think it's quite nice when it's named by somebody who doesn't come from that country. Then it's a genuine honour rather than a patriotic gesture. And of course, England had just lost the American colonies, so it was a particularly nice gesture. Hatchett, unfortunately, didn't continue as a chemist, and he worked in a company that made carriages, I suppose the modern equivalent of a sports car company, and later in his career he focused on the carriages rather than on the science. The element was then rediscovered in Germany and named niobium. There was a problem because the Americans called it columbium, the Europeans called it niobium, and there was a sort of trade-off. It was agreed the Americans would call it niobium if the Germans and the Europeans would call wolfram tungsten. So everybody was happy. But niobium is actually a relatively abundant element compared to many of the metals, and by far the biggest deposit is in Brazil, where this company, CBMM, is a mining company that digs niobium out of the ground. Now the main use of niobium at the moment is in strengthening steel. Steel for making bridges, steel for making cars, steel for making pipelines that you use for high-pressure gas, like natural gas. So imagine this piece of paper is steel. If the steel was just a single crystal, if you put a force on it, like my pulling here, very strong. But actually, the steel consists of small so-called grains, rather like small crystals. The boundary between the grains is a weak point. So let me illustrate that by tearing the paper a bit. Now you can see if I pull again when there's this weak point, it just pulls apart very easily. So the grain boundaries is what causes the failure, and the pipe bursts if you don't make it thick enough. If you add just a tiny bit of niobium to the steel, less than 0.1%, less than 1 part in 1,000, the niobium concentrates along the grain boundary and strengthens it. Let me show you.
Molybdenum.
You imagine the niobium across this grain boundary.
Who named that element? Okay, if there's ever an element 119, can somebody please name it Apterium?
It's much stronger and it doesn't break. I'm pulling really hard. What this means is that if you add a small amount of niobium to your pipe, to the steel that you make your pipe, you can put a lot more gas through the same pipe. There's a pipe in China which is 8,000 kilometers long, and by adding some niobium and making the pipe a little heavier, 1¼ times heavier, you can take 2½ times as much gas down the same pipe. In cars, the cars in developed countries like the US and in Europe, they add about 200 grams of niobium to the steel that makes up the car. And that saves 100 kilos of weight of steel in that car. It's almost the weight of a whole passenger. And so then, when you're driving, every 100 kilometers or so that you drive, that saves 1 or 2 litres of petrol, depending how aggressively you drive.
Professor, how does adding niobium make the car lighter?
Well, it makes the car lighter because the steel is stronger, so you don't need so much steel to make the same strength car.
But you said the pipe was made heavier in China. That's because the other things were...
Well, you made it heavier by a little bit, and then you could take twice as much gas in it. In the car, you just want to take the same number of passengers, so you can make it lighter and take the same number
Come on,
of
when are
passengers.
we gonna get into the actinides and the lanthanides?
Small amounts of niobium.
These elements start to get interesting when it gets in
The
those.
steel is rather like adding just a grain or two of salt to your cooking. So, in fact, the producers of niobium produce a material which is called ferroniobium, which is a mixture of iron and niobium, of which I've got some pieces here. It looks a bit black if you crack it open. And so this is the material that is added to the mix when people are making steel. Well, I believe
that was like a horror movie. I just looked,
America
got a
still
glimpse of
call
it.
it columbium, and I think that's rather nice. But it's not used as the name in chemistry, and in fact I think most chemists will no longer have even know the name existed. I like it. It rolls off the tongue so much nicer than some of the modern names for elements, the recently discovered ones. But it's also good because it reminds one of the history. And I think the discovery of niobium or columbium in a sample in a museum is a very good reason why we need to preserve things in museums, because very often scientists who come later can discover things that the people who originally collected the samples would never have dreamt of. The person who originally collected the sample where niobium was discovered didn't know that elements existed. So there was the sample just waiting for the future scientists to discover this. All right, yeah. So, the other application, element.
Okay, this one's gonna be a short one. That most of some saying, why would you put an ad on a 57-second video?
So, molybdenum is an element which is essential to life. And most organisms, beginning with you and me and going down to bacteria, have enzymes that contain molybdenum. One of the most important enzymes is so-called nitrogenase, which is an enzyme that will turn nitrogen into ammonia. And nitrogenase is found in various bacteria that live in the roots of plants like beans. So the beans, via these bacteria, can absorb nitrogen from the atmosphere and turn it into a form that we can digest. And we need that nitrogen so that we can make the proteins in our body. So without molybdenum, nothing could live.
Now that was the technium. Technetium.
One of the big surprises of the whole periodic video project for me was my actually seeing a sample of technetium. Before I tell you how I saw it, let me explain why I was surprised. Technetium was one of 4 elements that were predicted by Mendeleev to exist in the periodic table, but had not yet been discovered. He predicted it first to have an atomic weight of 100, which he then revised to 99, which was pretty accurate. So technetium is element 43, and obviously between molybdenum, which is 42, and ruthenium, which is 44. The real discovery came when 2 Italians, Emilio Segre and Carlo Perrier, in Palermo, in Sicily, were sent a sample of molybdenum that had been irradiated in the cyclotron in Berkeley. It had been irradiated with a mixture of neutrons and deuterons. Deuterons are the nucleus of deuterium. 1 proton, 1 neutron. And so Segre and Perrier were dissolving up this piece of molybdenum, which was highly radioactive, so they let it sit for a bit so some of the radioactivity decayed, just to find what was in it. By carefully precipitating and seeing where the radioactivity went, they isolated the first sample of technetium, but it was too small to see. But by its behaviour and the fact that it precipitated together with rhenium, they could tell that it must be in the same group. I think it was just sent to them because they were interested. Nobody expected technetium to be in it. And the technetium was therefore the first element that had ever been made synthetically. chemists who were looking at the structure of the periodic table felt that synthetic elements were somehow cheating, so it should not be put on the periodic table. Can you imagine that? The paper was published in 1937 and nothing happened till the Second World War. Then, in the Second World War, there was the Manhattan Project, the development of nuclear weapons, and lots of new synthetic elements were discovered, particularly plutonium, which had never been discovered before. And after the war, 1947, very shortly before I was born, there was a historic paper was published in the journal Nature by the German chemist Paneth, who during Nazi times had moved to the UK and was working at the University of Durham. He laid down the ground rules which exist to this day for the naming of elements. Number one, the right to name an element should go to the first, presumably group or person, to give definite proof of the existence of one of its isotopes. Second point, in deciding the priority of the discovery, there should be no discrimination between naturally occurring and artificially produced isotopes. And the third point, and this is very important, if a claim to such a discovery has been accepted in the past, but is refuted, that means contradicted, by later research, the name should be deleted and replaced by one chosen by the real discoverer. And those rules apply to this day. And it was technetium that really precipitated this. So what happened then was that the names of 6 new elements, including plutonium, were accepted, and Segre and Perrier were invited to name their element, and they chose the name technetium in the same journal, in a really short paper, from the Greek word which means synthetic. So it is embodied in his name that it was the first synthetic element. In the early 1960s, with the improvement of instrumentation, people discovered that in uranium minerals, because of the radioactive decay of uranium, you can detect tiny, tiny traces of technetium. And therefore, it is natural after all. So the name isn't quite right. And then in 1972, there was an extraordinary discovery by geologists in Gabon in Africa, where they discovered that in a uranium deposit underground about 1 million years ago, a natural nuclear reactor had started. There was a high enough concentration of uranium for a nuclear reaction to take place. And because of this nuclear reaction, there were in fact traces of technetium found under the ground. Because of all the nuclear research that was done during the Manhattan Project, there was an abundant supply of technetium became available after the Second World War, and people started studying the chemistry. And you can get a wide range of compounds. And as you might expect, the chemistry is perhaps a little closer to rhenium than to manganese, because heavier elements tend to be more similar. But one of the most interesting applications turns out to be in medicine. The application is in diagnosis. When people have cancer, it's often quite hard to see the tumours, or particularly the secondary tumours that spread across somebody's body, because they're small and they're not easily imaged. But it turns out that if you take radioactive molybdenum-99, it decays by emission of electrons to make technetium, but very unusually, and something which we've never talked about before, the technetium is formed with the nucleus in an excited state, that is, with higher energy than it might have otherwise. And this excited state is symbolized by the letter M, which stands for metastable, which means it's stable for a short time but not very long. And so what happens is this metastable technetium decays to the stable isotope, or stable state, but with the same mass, and gives out a gamma ray which can penetrate a large distance through, for example, human flesh. And then much more slowly, the technetium-99 decays to ruthenium. So what happens is that if you do your chemistry very quickly, you can isolate this technetium-99M And before it decays, you can react it with another chemical which will complex, that's bind round the technetium, and you choose this binding chemical so that it will also bind to tumour cells. Selectively, it will bind to the tumour and not to ordinary organs. So quickly you inject it into the patient, it goes round the body and is localised at the tumours. Then if you put the patient into a suitable detector or array of detectors, you can measure the gamma rays coming out, and the gamma rays will come out much more strongly from where the tumours are. And because the technetium decays rapidly, you can get a good signal to do your imaging without giving the patient a big overall dose of radioactivity. So now this brings me back to how I saw technetium. Some years ago, I went to Zurich University and met a professor, Rayce A Abbott, who's one of the world's experts in technetium chemistry. During the coffee break, Roger came up to me and pulled out of his pocket a little metal vial and unscrewed the lid and took out a glass container, and inside was a piece of metal coated with technetium. I was amazed. I never thought I would be able to see this. So I immediately asked him how he could get hold of this stuff. And he explained that one of his co-workers had used electrolysis, that's passing electric current through a solution, to deposit a thin layer of technetium onto a piece of copper. Now, you don't need very much metal, only a few nanometers, to see what the metal looks like, because light doesn't go through it. And in fact, this particular sample, I think, had probably a couple of milligrams of technetium on it, so it looked just the same as a large block of technetium would look. But I felt really excited, because here was an element which I'd seen sort of in brackets on the periodic table, and I never thought I would actually hold a sample in my hand, or I held the glass bottle. And because technetium decays by beta emission, that's emitting electrons, and these electrons don't penetrate through material very easily, even a small glass vial is quite enough to protect people, at least for a short time. So I could safely hold it, and in triumph I held it against my tie next to the symbol of technetium, and I felt I'd really made a discovery.
Hi there, thanks for watching this video. Of course, we have made
ruthenium.
Alex M. on Espresso Virtuo. In his own words.
One of the big surprises of the whole periodic video project for me was my actually seeing a sample of technetium. Before I tell you how I saw it, let me explain why I was surprised. Technetium was one of 4 elements that were predicted by Mendeleev to exist in the periodic table.
So this is a sample of ruthenium sponge. So the ruthenium metal has been precipitated to form very fine particles. So here, we'll just open the box.
I'm rather ashamed that I made a big mistake about the name of ruthenium. I thought it referred to somewhere in Middle Europe, perhaps in Czechoslovakia, whereas ruthenium actually comes from Ruthenia,